Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the solution process. Last time, we learned about liquid solutions and interparticle forces of attraction. We learned about the three types of interaction that affect the tendency of particles to mix. We also learned about the like dissolves like principle. This principle states that if there are two substances that have similar intermolecular forces and are of a similar magnitude, then they are likely to be soluble with one another. We discussed how this can be used to predict relative forces of attraction. You have also learned the definitions of rate of dissolution, heat of solution, salvation energy, and hydration energy with your classroom teacher. In today's lesson, we will discuss the endothermic process. We will explain the term heat of solution, and we will apply this concept to a solution of ammonium nitrate crystal. We will display the energy change in the dissolution of ammonium nitrate crystal. Students, do you remember learning about the three steps involved in the solution process? As a review, please list and explain the three steps now, and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I trust that you did not find this activity to be too difficult. Let us go through the steps together. First, the solvent molecules separate from one another to make room for the solute particles. Second, the solute molecules separate so they can merge into the solvent. Finally, the solvent molecules mix with the solute molecules. If you correctly described all 3 steps, well done, students. If you had trouble with this activity, please review the information we learned in our last lesson or ask your teacher for help. Let us discuss this diagram a little further. As you can see, both the first and the second step require an input of energy. This energy is needed in order to break the attracting forces between the molecules. The heat of solution is the amount of energy that is needed for 1 mole of a substance to enter the solution. This is the sum of the enthalpies associated with the 3 steps in the solution process. Students, which steps in the solution process are endothermic? Please explain your answer.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. How did you do on this activity? If you said that both step 1 and step 2 are endothermic, then you are correct. The separation of solvent particles is endothermic because energy is needed to overcome the forces that hold the solvent particles together. The separation of solute particles is endothermic because energy is needed to overcome the forces holding the solute particles together. Well done. As you might have guessed, these two steps are not necessary for the solution process of gases. The molecules in gases are already widely separated. Let us discuss the heat of solution. It is the enthalpy change associated with the dissolution of a substance in a solvent at constant pressure. This results in infinite dilution. The heat of solution is the sum of the energy absorbed or the energy change for endothermic process and the energy released or the energy change of the exothermic process. The energy absorbed is expressed in values that are positive, while the energy released is expressed in values that are negative. Both are expressed in terms of kilojoules per mole. Thus, the heat that is either absorbed or released as a solution is formed is called the heat of solution. Let us discuss an experiment that will help us to investigate the heat of solution. For this experiment, we require an Erlenmeyer flask, a thermometer, and a cork. We also require ammonium nitrate crystal and water. We begin by pouring 50 milliliters of water into the Erlenmeyer flask and placing a thermometer into it, as you see here. We record the initial temperature of water as it is displayed on the thermometer. Then we remove the cork and the thermometer and add 4 grams of ammonium nitrate. When the solution reaches its maximum temperature in either direction, we record that temperature as well. We can use the initial temperature and the maximum temperature to figure out the heat of solution. For liquid solutions that are formed from a solvent A and a solute B, an ideal solution forms when the A-B interactions are the same as the AA and BB interactions. In an ideal solution, the heat of solution is 0. When the A-B interactions are weaker than the AA and BB interactions, particles in the solution are less attracted to each other than they were in their pure form. Therefore, the heat of solution is greater than 0, and the process is endothermic. In our experiment, the flask containing ammonium nitrate is cold. Therefore, the solution process is endothermic. Heat energy was used in order to produce the solution. In today's lesson, we reviewed the steps in the solution process. We discussed that the first two steps are endothermic processes. We also talked about the heat of solution. We learned that it is the amount of heat energy absorbed or released when 1 mole of a substance enters solution. We finished our lesson by discussing an experiment which combined ammonium nitrate crystal with water to produce an endothermic energy change. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.